Hi, and welcome to Spaminar, the Society of Prop Managers webinar series for live theater prop professionals. I'm Kristen Ward, SPM member and assistant props manager at Carnegie Mellon University here in Pittsburgh, PA. The Society of Prop Managers, known as SPM, was formed in 1994 by a small group of prop professionals in the Midwest to address issues of common importance and to create parity with other production departments. Today, we are an association of 150 plus professional prop managers and educators from not-for-profit producing organizations, opera companies, and educational institutions. We've built an international communication and support network that shares resources, information, solutions, and techniques, as well as safety information, continuing education, and stock. As with previous Spaminars, we're requesting pay-what-you-can donations to help support this programming and our annual grants for early career prop professionals. If you can afford to donate, links to donate will be in the chat. We truly appreciate any help you can give. We have enabled live transcriptions for this webinar. If you'd like to use them, click on the live transcript button down on the bottom, and then select Show Subtitle. Alternatively, you can click View Full Transcript to see it in the meeting side panel. I'm joined tonight by SPM member and our resident 3D printing expert, Sean McArdle. Sean has been in the prop world for over 30 years, having worked at the Public Theater in New York City, the Guthrie Theater in Minneapolis, and many others. He has a master's degree in prop management from the University of Illinois Champaign-Urbana. He's the founder and sole proprietor of Hero Props, a Minnesota-based prop shop for over 16 years. Through Hero Props, he does work for theater, museums, cosplay, corporate clients, and more. Please feel free to ask any questions you have in the chat, as we'll leave room at the end to pose all of our questions. Over to you, Sean.
There it is. Hi, everybody. Welcome to my studio. I'm here in my studio here in St. Paul, Minnesota, where I do most of my work. I will probably not going to try to move the camera around a whole lot during this, but I'll do a quick pan so you can see this is my 3D printing farm over here. I have about 15 3D printers, maybe 20, I don't know, I lose track. I have a bunch that do a variety of different tasks depending on what I'm asking them to do. I'm going to try to go through very quickly in about 10 minutes and talk about just the basics of the mechanics of 3D printing. And then I'm going to try to go, I've got a list of things that I want to touch on how I have incorporated 3D printing into my own workflow, because I've only been 3D printing since the pandemic. I picked it up about halfway through and just started taking off with it. My first printer was a Prusa Mini from the Czech Republic. And it just was like someone handed me a Star Trek replicator. And as a result, yes, thank you, Patrick. Yes, all of my printers are actually named after robots and droids. So I think it's very accessible and easy. And I've been trying to make it an add-on to my own mission of spreading the gospel of props, to spread the gospel of 3D printing. And showing how it's accessible, why you should have it in your studio or school or shop or whatever, and how accessible it is now and how easy it is now. 4 years ago, 5 years ago, when I was just starting this, it was still very difficult and it's very tinkery. And a lot of my machines that I have over here still require a lot of tinkering. But the new machines that are available right now, and I'll just say the brand right now because it's the one that I'm going to recommend, is Bamboo Lab. They are the most accessible printers, and I have 2 of them, and I have one of them right here. And it's the one that if you were going to start with one machine, I recommend starting with this one because it is only $200. We are very lucky here in the Twin Cities because we have a vendor called Micro Center, and they have a fantastic selection of 3D printers and materials, so I can buy everything locally. But these things are also obviously available online. They want to keep this printer accessible and cheap so that more people can get into 3D printing. So I am currently teaching a 3D printing after school program for after school kids, middle schoolers. And so 6th to 8th grade. And this is the machine that I've been teaching them on because it's so darn easy to use that I'm actually going to demo it a little bit while I'm talking about 3D printing. One of the things that you learn quickly when you're doing 3D printing is that you are needing to calibrate your prints. And there are a lot of different ways to do that. And the basic way to do it, the way everybody does it, is you print one of these little boats. It's called a benchy. And what a benchy does is it has every challenging geometry that you will run across when you're 3D printing, because when this boat prints, everything needs to be supported. And what this is designed to do is it doesn't need any exterior supports, but it wants to be able to have your settings correct so it can do an arch like that, so that it can do the porthole, so that it's going to get the little smokestack correct and get the finish on the side of it. It's got these little anchor holes there for the rope right there too. So I printed one of these just a minute ago using some TPU, and I wanted to go ahead and just quickly show the process because I think it'll be indicative of how easy it is to do these things. So I am going to go over here and I'm going to unload this filament. And while it's doing that, I'm going to explain exactly what this sucker is. 3D printers are not that complicated. I like to liken them to, it's a robot hot glue gun. That's pretty much what it is. There's a little metal nozzle in here, little brass nozzle that looks a lot like the one that's on the end of a hot glue gun. And it heats up in much the same way. And it uses filaments that are much like hot glue because they're a thermoplastic. Now they're a lot smaller, it's a lot thinner. They come on rolls. Sometimes they're plastic rolls, sometimes they're cardboard rolls. The filament is 1.75 millimeters in diameter. That's the standard dimension of what is used with most hobby level printers these days, which is what were commercially available printers. So the other thing I like to liken these two is, it's also a lot like what I now call a 2D printer. So the printers that we have all used for years to print documents on paper, in practice, are not that dissimilar from this. In fact, the newer printers are becoming more like that. So what it gives, and the beautiful thing about this little machine is it gives you instructions as you go, and it tells you what to do. So what it just did is it heated up that nozzle hot enough to melt the plastic so that I can remove this roll. So I'm going to take this roll off the printer and put it aside. And then I'm going to install this new one. So put it on the roller, feed it right through this little hole right here. It goes through this hose, this tube, until it gets into the extruder. I tell it to load. It's going to heat the nozzle back up again, and it's going to pull that heated material into the nozzle, purge the old material, and then it'll be ready to start printing. These printers are so easy to use that I pulled one of these things out of the box in an hour-and-a-half class with 6th graders, and we were printing benchies in less than an hour. And so that's what I want to print right now. What I'm doing is I'm loading this with high-speed PETG. which is a very dense, strong material. I'll go ahead and mention those different kinds of material that are available right now. Most of the time we use something called PLA, which is a corn-based thermoplastic. But there are other ones. There's ABS, which is a material that is ubiquitous everywhere. You probably have touched an ABS object today if you touch something that was plastic. PETG is one of the stronger materials that I've been using. It's a little bit stronger than your standard PLA. So if you're needing strength in your project, it's a good idea to go up to that. And then there is flexible TPU, which I'll get into. And there's also a flexible PLA that is available. But what I was saying about it being like a regular 2D printer is you're used to watching that head on a 2D printer go back and forth. Same thing with this. But with this, there's no paper, but you'll also notice that this plate down here will go back and forth as we're going through. The key with 3D printing is you want to make sure that your print is in there, is going to be stuck down correctly to the plate. And so there are a few different ways that you can do that. These plates are great because they come with a magnet. It's a metal textured plate, and this is a magnetic thing, so it just goes on there. So when you get done with your print, you don't have to worry about it sticking too much because you can flex the plate and it'll pop off. Here is my first secret tip, and I think a lot of people of my cohort and older are going to appreciate that. Old school Aquanet is the best adhesive for 3D prints that I have ever found. And all you do is just spray an even coat of it on the plate, and it provides a sticky surface that helps your material stick to the plate. Oftentimes, the companies will tell you to use a glue stick. Don't use a glue stick. It's way too sticky. It's too textured. This gives you a nice even coat. And when you get too much of it on there, all you need is some isopropyl alcohol, and you can spray it on there, dissolve it, clean it off, start over again. So what all of these printers do is they make a three-dimensional object using a thermoplastic. It doesn't get much more complicated than that. So it's much like I said, like a 2D printer. It goes back and forth. Only this plate goes back and forth, and that's the plate. And then the third dimension is up. So it's imagine if they were writing a document on your 2D printer, your regular printer, but those letters just kept getting deeper and deeper and deeper. That's kind of how it works. So as I'm talking, I'm going to let this thing go. It's going to heat up, and it's going to start printing a benchy. My favorite thing about this, and we'll maybe try it, there are different speed settings for this little printer as well. And I'm going to have it set as 100. I've got it set as 100%. I'm going to speed it up to ludicrous speed because they have the capability to go to 166% speed. And so we will be able to, hopefully, if I'm lucky enough, if it gets the layer right the first time, and it usually does, it's a very dependable machine, it's going to run through its process, and we'll have a little boat in a few minutes. I could talk for an hour and a half or 2.5 hours and do on a regular basis. I also teach a full 3D printing 101 class that covers with pretty much everything, which is I'm trying to limit this to just a few minutes of explaining what the basics are so that I can show you more about different ways that I've used it to make the props specifically. It's right now what it's doing is it's going through a calibration process where it will go through and measure the plate to make sure that it's level. And then once it knows everything is all copacetic and happy, then it'll just start going to town and start printing. Where's my next thing on my list? There are a lot of things that go into getting from point A to point B if you're making your own models, and I'll get into that in a little bit. But at its heart right now, I don't think there's any reason not to get a machine like this for your shop. It's so cheap and it's so accessible, and you're about to see what it can do and how quickly it can do it. And then I'm going to show you a lot of other things that you can do with it. There are things that you'd find that you need to know, like there's slicer programs that are, but that's another thing a lot of people ask about is how expensive it is to get into this. And the answer is it's really cheap because mostly the software that you use is open source. I use a slicer called Orca Slicer, which is based on the slicer that Bamboo, who made this printer, came up with. And it's also based on Prusa Slicer, which is another slicer program that I use. And what those programs do is they take a three-dimensional model and they turn it into something called G-code. G-code is a code that has been being used since like the 70s. And it's like when we watched those automated factory videos on Sesame Street where they were showing you how donuts are made or bagels are made, and you see all of the machines and the belts and everything moving, those machines are working on G-code. It's the same thing. And now the open source community has figured out how to adapt that G-code and tweak it and figure out new things that they can do with it. One of my favorite things is something called vase mode, and I'll talk about that where it, with some of the other projects, but what it does is mostly what it usually does is it prints a layer and then it goes up, and then it'll print another layer and then it goes up. And that's what the progress is. And the trick is you want to make sure that those layers are stuck together, and you want to make sure that they're stuck to the plate. There are different ways that you can do different levels of quality. If you have thicker layers, they'll go faster. But you're also going to be able to see those layers, and then you got to go back and fix them, usually, sometimes. But it also may be that you don't need to. And I'll explain what I mean by that a little bit later, because oftentimes in the 3D printing world, the goal oftentimes wants to be making things as perfect as possible. But I have found that sometimes that's a great goal, but more often than not, I just got to get close, because I can print something that will so very quickly be done. And then I can go through and smooth it out. I can go through, sand those surfaces down so that there's nothing. And then suddenly I'm back in the same old world of using prop making materials that I have for ages. And this ends up just becoming a new tool in the toolbox. And that obsession with taking these prints and making them perfect, like you can do incredible levels of detail on these things, but it doesn't matter. It's a trade-off. It's a trade-off, because especially when I think about how I use this as a prop making tool, speed so often is of the essence because of how quickly we need to work as prop people. So I love how fast this goes. So I won't go too far down that rabbit hole of explaining how 3D printing works in general, because it's a deep rabbit hole. One of the things that I will do and will make accessible is I have a cheat sheet that has a lot of my favorite links to a lot of different YouTube channels and Patreons that have a lot of that nitty-gritty detail that you need to know, depending on what kind of printer you have. But I'm happy to tell you that we have entered a world where this is becoming so much easier and more accessible that it doesn't become the time suck that it once was a few years ago if you wanted to get into this. I would say 5-6 years ago, depending on what kind of printer you were getting, it wouldn't have been worth it yet, but it is now. Base mode is literally what it sounds like. The nozzle never changes direction. On a regular print, oftentimes you will end up with a seam. And you can tell it in the slicer where to put the seam to make it go away so that it's not noticeable. But when you're doing something in vase mode, it just goes in a constant circle. It's like a tiny, tiny incline. So as you go through, you can see that there are no seam in this because the nozzle never stopped going in the same direction. It never switched direction. So it created a perfect print. This is going a little too fast now. I'm going to slow it back down to standard because we're starting to lose a little bit of adhesion, but the boat is still working pretty well. Another thing about this, and one of the things I think about a lot in terms of like the larger scheme of how we end up spending our prop budgets, especially if you're doing tricky stuff like this. You got to order a bunch of weird parts from McMaster-Carr, and then you don't know what those parts are going to be until you get them. Because here's another fun little trick. You can download CAD files from McMaster-Carr and you can 3D print them. That's so if you need a part that's in metal, but you aren't sure it's actually going to fit, you can download that part directly, the CAD file directly from McMaster-Carr, and print it in real size, and then you'll know that you have the right piece. What else? So that's what. So I think it's easy to make the case for them paying for themselves very quickly, and then once you get started with it, then you can decide whether you want to go bigger to get a more expensive printer. But this is the perfect one to start with. Because it's a replicator. It's a Star Trek replicator. And it can increase your workflow in just the craziest ways. What else? I can talk about how it accelerated the prototyping of a project. So one thing that I have come up with lately, and if you've been on my social media at all, you have heard this. I really love these new Sharpie creative markers, but they don't come with a holder. So I wanted to come up with something that would hold them. They were just in a blister pack. So I designed and built my own container, my own holder for it. And then I used it as a lesson in my 3D printing class with the kids. And I showed them, because this is one of the things I mean about accelerated prototyping. You can make little pieces, parts that you can print test pieces of. So what I did is I just made my whole model, but then I sliced this little part just to make sure that the pens would actually fit in the holes that I was making, so that I didn't have to print this whole thing to make sure that it worked. I could print it in pieces and print it in sections. And like, this is one of the intermediate pieces of just one of the single parts. And I had made it so that it needed a little bit more support, and was able to then redo it and then know that it was stronger. So before I committed to printing the whole thing. And this is another thing, I'm not gonna go all the way into it, but because it could be a whole nother class, but I do most of my work on a program called Shaper 3D, which is a drafting program. It is iPad based. It's parametric CAD modeling. And I actually can do it. And I am a prop guy who's been doing napkin sketches since the 90s. And in the last couple of years, along with the 3D printing, I'm now doing my own CAD on an iPad. And that's something I'm starting to teach the kids now too, because it's just as accessible. As you can see, this sucker can just go. It prints so fast. And so if you have that widget that you need for the show and oops, it broke, you can have this backstage in a run crew room. What else? I love to use it to hack other tools. So one of the things that I've done is, yeah, I'll explain that. Actually, we're gonna this thing will be done in just a minute, and then I'm going to show a couple of pictures and videos, and I'm also going to put this video up so I don't have to keep crouching down so that you can see the printer working. But I think it's important to see that it's really just this simple. And I think it's great that I can just print a silly little object like this in like 10 minutes, and as a demonstration of, just think about what you can do if you could make your own object, make your own widget, make your own prop that's not dependent on, say, ordering something from China, ordering pieces parts, that widget that you needed from Amazon. Because oftentimes what I end up doing is replicating my own. I've gotten really good with calipers and combined the calipers with working on Shaper 3D, and I can replicate my own parts and make my own parts that increase the number of things that I can do almost exponentially. Just the other day, I was working on a thing, and I realized that I didn't want to, I'm going to need some rosemary. So I 3D printed some rosemary. I used it on another program that I will show you really quick on the iPad. It's called Nomad Sculpt. And it's like a sculpting with clay on an iPad, and you can import images into it. And so for this, I actually imported an image of some rosemary and turned it into rosemary that I could print and use for dressing on a prop. There you go. What else? Nope, our boat is almost done. So yeah, I like to use it to hack other tools. And actually, my whole kind of thing these days has become that I'm combining 3D printing with all of these traditional techniques of prop stagecraft that I've learned over the years. And so here, we're almost there. So, and if you see my social media, and I'll bring up some images in a minute, but I have done, I do a lot of cosplay, and I'm doing a lot of museum work. I'll show you these cosplay parts really quick. We'll get to a picture of it too, but this is a cosplay piece I made for a convention a couple of weeks ago. It's made out of flexible PLA. It's one of the X-Men. He's a mutant who is growing mushrooms out of his cerebellum. So I made this piece on my iPad, 3D printed it in flexible PLA, was able to wear it for the weekend, drew it, colored it with these amazing markers, and they're color fast too. They're acrylic water-based markers, and they're color fast and they're great. But I had to rapid prototype it. You can see this is a prototype piece that I did as a test. This is in a rigid material. This is the flexible. And so if you're making like costume crafts pieces, I wanted to make sure this fit on my head before I committed to printing the whole thing. So, and it was all in pieces on the iPad. And I made basically a little skull cap that I knew would be pretty close. And I was able to actually use a pair of traditional calipers like these, very useful, to actually measure my head to make sure that I had the right distance back to front. And then what I did is I literally sliced. Oh no, it came off the plate. Not enough. Right at the very end, it came off the plate. You can see, but it almost made it. That's what I get for trying to speed it up. But it had, so this is a piece, the flexible PLA, and I was able to, in the slicer program, cut just a cross section of it, and then take that and then put that on my head, and then I knew it would fit. And only then did I commit to building this whole thing. Here's another example. Boat. It looks like crap because I went too fast, but proof of concept. That's how fast this silly thing works. And it sounds like a video game. I love it. So another example, I'm starting to build some armor. I have a whole set of Mandalorian armor that I'm in the process of making that was made on this website by this fantastic dude that has a Patreon down in Australia called Hex 3D. And he does all of this stuff in a program that many of you may have heard called Blender, that also can do animation and a lot of other things. If you know how to use it, kudos. It's beyond me. But that's what he did with this. But as an example for costume crafts and props, I wanted to make sure that I could put this helmet on over my head, but still have it clear my glasses. So I printed a full cross section of it, just straight up. And then I printed this and realized, nope, too small. It's gonna hit my glasses. Then I had the bigger one. Oh, this one clears. So now I knew that I had the print at the right size and only had to commit to a tiny amount of plastic. And this thing only printed in probably like 10 minutes, as opposed to that helmet, which takes something more like 36 hours, 24 to 36 hours to put something that large. So yeah, accelerating prototyping. It makes things so much quicker to go from concept to finished product. Before I get away from like the basics of 3D printing, another little thing, little trick, couple of products that I like to use. This Super Weld, JB Super Weld, is an ultraviolet resin in a pen. It actually has a little ultraviolet LED on the back end of it. And so what you do when you first open it, it punctures the hole, and it uses clear ultraviolet resin that hardens under hard light. So you can kind of use it to spot weld something if you've got to glue it together, like the PLAs, because you can use super glue, cyanoacrylates work with PLA and PETG most of the time. I find that it's hard to trust them sometimes. It'll get brittle later on sometimes. It depends on the quality of the cyanoacrylate, the super glue that you're using. But my favorite product that I have found is the plastic bonder from JB Weld. They have more than one kind. They have a plastic epoxy, like a 5-minute epoxy. This is 15-minute working time, and it comes in natural and black. Much prefer this to the epoxy, both because of the working time and because you can sand and cut it afterwards too. So like if I was printing something that's black, which is something that I have done quite a bit of, use a black PLA, you can use the black plastic bonder, glue that sucker together, and you can't even see the seam anymore. What else? Hacking other tools. Let's go look at some of the things I wanted to share in this folder. Let's start here. A few years ago, I got to build a project for Marvel for the Spider-Man 60th anniversary museum exhibit. We started at the Comic-Con Museum a couple of years ago, and I 3D printed those tentacles. He is a full 9.5, about 10 feet tall, and those tentacles are made of rigid black PLA, and they're covered with vinyl. I didn't even paint it. I found that adhesive vinyl actually ended up working the best. And so part of the reason that I share this is because I was able to incorporate some old traditional theater tricks when I made it. So this is one of the sample pieces, and it's a little rough, but you can see it's vinyl and metal tape. And I made the ink lines a little bit raised so that it had something to cut against. So I was able to do this whole thing without any paint. And actually the final step ended up being actually sharpieing the ink parts with actual big, thick, fat Sharpie. Prints oftentimes will come out very rough, especially on the underside, but even on the outside of this one, the layer lines were very obvious. Lots of different techniques for getting things smooth like this. sanding is the first one, and making the walls of your print very thick so there's plenty of plastic there to work against. But one of the things that I have discovered is that you can use the ultraviolet resin that is intended for resin printers, which is the other main kind of 3D printing that is available, where you're using an ultraviolet resin that hardens under UV light to create the models. I'm not going to go into that style, but it's really good for detail. People like to do like D&D miniatures with that kind of thing. I've had some luck making some glass bow tiles with it. Smells, though, depends, because it's resin. But it comes in a variety of colors, and it hardens under ultraviolet light instantly. So you can put a small UV light on it, and depending on the intensity, it'll just harden it right away. And that's what I did with this is I brushed black resin onto this, and we sanded that. And that was a quicker, easier way to get rid of the lines. And then there was this other project that I did recently where I was able to make a large sculpture of a dragon. It was a dragon egg. And they gave me a big model. It was like 3.5 feet tall. I was able to take the egg and cut it into about 25 pieces in the slicer program, and even put little dowels into it so that everything would line up correctly. Glued it all together, filled some of it with some foam, because I actually used some great stuff foam. That's what you can see in the back in order for some strength, but was able to make this thing on my larger format printers with a larger nozzle, a 0.8 millimeter nozzle, and was able to crank this thing out in about a week and a half. And this is what it ended up looking like when it was done. Now, the layer lines on this thing were very, very obvious. And so what I did to get past that, I'm still really excited about, because this is what it kind of looked like coming off the printer. And if you look close, you can see that it's rough. You can see that there's a lot of texture to it. It's even worse on the inside, but that was my trade-off. I wanted to print really fast, and knowing that it would have that. And then what I was able to do was take that resin and brush it on in sections and harden it. And then that hardener reinforces it, and you can add the color. I happen to have this color was pretty much the exact same color as this. So I was able to do a first coat with that. And then I went over it with a translucent red filament, which gave it a little depth. And then you want to cure this kind of resin with alcohol, with isopropyl alcohol. And so I combined a final step. I figured out that you can put colored inks into these resins. So I was able to just put some black ink to the resin, and that's where I was able to get that depth of color. And it went so fast that it could have gone on stage instantly. In fact, I put it in a box the next morning and shipped it to Austin. But I could, like minutes after I was done with it, because it doesn't have any dry time beyond the alcohol, and it's alcohol, so it dries really, really quick. Hacking tools. I love to figure out different ways that I can hack existing tools. Here's a basic example would be I've got an exhaust fan over there from Harbor Freight. Love to hack Harbor Freight tools. I had some tubing that was this 6-inch tubing, but that thing has an 8-inch opening. So I was able to quickly design an adapter and be able to print this on the printer and just create my own custom hose adapter without having to worry about going anywhere and shopping for it. Then this project, if anybody is actually around the Twin Cities, I highly recommend one of my favorite places is Can Wonderland. It is a venue in Midway And a couple of years ago, last year, they hired me to build them a new front desk, shaped like a pontoon. Original concept was maybe we cut a pontoon in half and turn that into the desk. But I thought, you know what? I think I can figure out a better way to do it. And so I made this thing from scratch. There's a couple of different angles on it. The seats are obviously not from scratch, but all of the aluminum on it, I bent using a Harbor Freight tubing bender and a metal bender that's like a Hausfeld bender. And I will show you exactly what that means, because I didn't weld any of that. It's all put together either with, well, first I'll show you these two videos of how I bent the material. Oh, looks like maybe they didn't make it in this folder. But what I did, I actually have the thing here. I don't need the video. This is a tubing bender, a tubing roller. And it is designed, it comes from Harbor Freight, and it comes with these dies, so you can take circular tubing, conduit, and turn it into hula hoop. And you can also buy aftermarket parts for it, so that it can turn, you can use other materials like a square tubing. You can even do it so that this will work with steel. But I didn't have any of those things, and I couldn't afford it. But I was able, by 3D printing my own little dies, to take 1-inch aluminum and bend it into my own thing, to the size that I wanted. And it actually polished it as it went. And then I used a small version of a Hausfeld bender and was able to get the tighter bends in that for the doors. What else out here on my table? Other examples that I wanted to pull up. I'm currently in the process. I mentioned that I was working with flexible material, TPU. And what I'm in the process of doing is building a bunch of props for a new production of the Nutcracker for Oklahoma City Ballet. And so there's this dream sequence where everybody is like they're shrunk. So they wanted these oversized props. So this is the carrot. And so what I'm doing is I'm building this out of flexible TPU material with 2mm walls. This is one of my Ender 5 Plus machines. It's from Creality. And so I've got a large nozzle on it. I'm doing relatively large layer height. So this piece probably printed, I think this piece probably printed about 12 hours. And it's about a foot tall. So I was able to print the 6-foot carrot in 1-foot sections. And this is a trick an old buddy that was working for Cirque du Soleil had turned me on to it, because they were doing this a while ago using this flexible TPU, because you can see this is one of the cross-section test pieces, and you can see how flexible it is. So what I'm going to do, and to my delight, I discovered that this plastic bonder works with the TPU. I didn't know if it would. It works great. So I will be able to glue this whole thing together, and I'm actually going to fill it with polyfill. And it's going to be a 6-foot high carrot that you could drop from the second story and it will just bounce. And it will be only about 10, 12 pounds. So it'll be light enough for the kids to be able to hold it. So there's a carrot, also a fork that's 6 foot. And then here's another stagecrafty thing that I wanted to point out. I don't know if you knew this, but you put steam through PVC pipe, you can turn it into a noodle. I think I've got a video of this on my Instagram somewhere. I'm probably going to share a bunch more things of things I'm referring to in this video today, just so that there's better reference for it that you can go back to and look at. But This is so useful because you can use, and what I use is one of these Jiffy steamers that most costume shops have to keep their costumes unwrinkled. And so I have hacked mine, so I just have an adapter that adapts took the wand off the end of the tube, and you can hook it up to the end of a piece of PVC, put a rag or a sponge in the other end of it to kind of cap it just to hold most of the steam in. Do not cap it completely because then you turn it into a pipe bomb, and that's bad. But you hold that steam in there just enough that it keeps the heat in, turns it into a noodle, and then you can put it into whatever shape you want. So that's how I made those tentacles for the Doc Ock sculptures really, really strong, because kids were hanging on that thing. It was a photo op. They were brutal to it. So it had to be crazy strong. So on the inside, what I did is I created a channel for the PVC. And when I assembled each of these tentacles, each one was about 10 feet long. So it was 10 linear feet of these tentacle pieces. I was able to heat up the piece of PVC and lay it right into the track and have it follow the entire length. And then as soon as you remove the heat, it hardens in that new position and remembers it. So there was a one long 10-foot piece of 1-inch PVC as a spline between all the pieces, which once everything was all glued together with the plastic bond or everything reinforced itself, and it was super strong. It's been through 2 museum exhibits now and hasn't had a break, knock on wood. And I'm happy to say I'm told that museum exhibit is going to be in Chicago in the spring, but it hasn't been announced yet, but it should be happening. That should be happening soon. What else did I want to share that I had photos of before we go to questions? This is a fun one. Just to show you the kind of level of detail that you can get on this little printer. This is one of the very first things I printed. This is Dogpool from the Deadpool and Wolverine movie. And what it is he's been supported using organic supports. So every place you see one of these weird little tree structures, what it's doing is supporting an overhang that wouldn't print correctly, which is exactly what's happening right there. That piece wasn't supported, so it ended up like a little spaghetti monster because it didn't have the support. The rest of it was great. And that's, here he is right here. And the level of detail and this is off this $200 printer. Like, look at the zipper. There's a little undercut under the zipper. The zipper actually has that level of detail. I love this stuff. Here's another thing. These printers can print a gap. So this is an articulated print, completely flexible. It's like a chain. It prints a chain. So this was just on the plate, curled up into a ball, and then you just peel it right off the printer, and it looks like this. Fidgets are very popular in the 3D printing world these days. My kids are incredibly thrilled about that. A few other things. I was mentioning vase mode. I use vase mode on these. These were for Seattle Rep. They needed replicas of glass lamp chimneys for a chandelier. Couldn't find them. Couldn't find one, much less the number that they needed. I think she needed like 16 for it. But I was able to print these in vase mode. And I think each one of these prints in vase mode probably only took like a half an hour. It goes really fast. And if you put a clear resin on this, you can actually make stuff clear. Because this is transparent PLA. And so you can, if you are careful enough, you actually can get a smooth surface on this and have stuff look like glass. You can do that with resin printing now too. But the most important thing is it was a chandelier, so we didn't have to worry about these pieces breaking. And if one does break, you can fix it. You can replace it really quickly. I make a lot of replicas of things. these are actually the Grammy Awards for the MJ musical on Broadway right now. I've been quietly running a bootleg faux Grammy Award operation. And another fun trick that you can do with things like this is incorporate hardware directly into your model. So when the base part of the turntable is printed, it has voids inside the exact size of a 1032 nut. And you pause it when it gets to the top of the hole. It prints the hole. You tell it to pause, stops, and you go doop, 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 doop. You stick the nuts in, and then it keeps going and it traps the nuts inside. And then there are 4 holes here on the bottom. So then I can just take those 1032 hex screws, go through the bottom, and this is actually screwed down mechanically. And if you look here, this is actually another 1032 bolt. There's a nut in the cone that is at the angle so that it receives this thing perfectly. So that's what's keeping this strength in place. And this is all made out of PETG. And it also had to be super light because it's used for a bit in the show where 7 of them are being held. So that's why there are these little holes so that they can be tied together with elastic cord. Flexible PLA, crazy useful. Just scratching the surface on that. Mold making is something I'm just starting to get into. I figured out that you can, like, I had a project where the client gave me a model that I was able to print, and then I designed my own 3D printed box that went around it and on my iPad, and then calculated the volume of what was going to be necessary for the silicone. So I knew exactly how much silicone to use when I went to pour the silicone for the mold. And I knew exactly how much resin to use to make the final piece, cutting out so much of the waste in the process. And then this other wacky little project I did, another example of how big nozzles and large heights can help on something. This is a mold I made for a project where I was doing an anatomical model of a cat. So I 3D printed the guts, modeled and 3D printed the guts and the skeleton of the cat. And then I put this inside an existing bought model of a cat, a toy cat. And then the idea is, there were 2 of them. One was skinny, one was fat. And it's a tool to figure out how your cat's supposed to feel when it's healthy, so you can feel the bones through the skin and the fur. So I made these molds so that I could put this expanding silicone foam on the outside of it, and was able to print these things very, very quickly, and then seal them quickly with ultraviolet resin, and do a very, very quick from idea to actually getting it a completed product using this really cool smooth-on product called Somafoma. I love doing, there were some pictures of it in the opening. I love doing period vintage radios and lighting. This is parts of a sign that was in the opening that I did for my hometown movie theater. Some Art Deco signage, glow in the dark, luminous filament. It's glow tape, only on a roll. So you can print glow tape. You could print these out of luminous. So if you had it on stage and you need your actor to go over and find it in the dark, you turn off the lights and it's sitting there glowing, and they can go quick and find it off stage. You can print your own little widgets that you can put on the corner of a piece of furniture, and you can screw them in so you know that the thing's not going to fall off. So many different things. They come out with these new materials all the time. There are new materials that will have glass fiber or carbon fiber. They have ones that have wood embedded in the filament, so it supposedly makes this, you can stain it, but you really can't. But poly shades on top of a brown 3D printed thing, you can make stuff look like wood really fast. Um, it's just, it blows my mind, the things that the possibilities that this opens up. All I've talked for 55 minutes straight. It's probably time for me to actually finally take some questions. I hope that everything I've said so far makes sense. I haven't had time to look at the questions as we go. So
Yeah, you had some great questions too.
hit
There
me.
were two questions from Paul around the technology of how something goes from being a drawing or a concept to coming out of your printer. Like, what's the
Sure.
technological stuff that happens?
Sure. Usually I'm using Shaper 3D on my iPad. That it tends to be the way that I usually work. And so the workflow is usually coming up with the idea of whatever I need to make. And in this case, like, let's say, well, I actually can show you a current project that I'm working on right now. In addition to that carrot, I am in the process of making a project of making a camera. Of course, I'm not going to be able to find it on this iPad. It's going to be on the iPad that the Zoom is on. Here, I'll find a different one. One of the ray guns. I will, if I'm making a retro project like a radio, and right now what I'm actually doing is I'm making a vintage land camera that from like 1910. I go to Google patent search, and I will find the patent drawing of the original thing, and will be able to draw directly onto the piece. Or like this silly example, I made the charm from the Deadpool and Wolverine movie. I was able to import the actual poster that I downloaded off Facebook, trace on it, extrude it, and that's how I created that 3D model, that really simple version. And I've done a lot of magnets that way. I made this ray gun off a photograph doing the same thing. And I was able to get like these levels of detail with it. But that has become what most of my workflow is. Or adapting something you can get. That's another thing I should mention, is that there are a lot of websites out there called like Thingiverse. It was the original big one. There's Printables, which is from Prusa, which is one of the very popular ones these days. I've started a little bit of sharing some of my models on there. But so many people in the communities will share models that you can download. And that was actually, I was able to do some of like that cat dog work. I was able to find models that veterinary students had created of the skeletons, buy those models from them, and then use them for my own work, because people will either release their models on a Creative Commons license or a limited use. Sometimes a lot of people just do stuff for free as long as you do attribution, you're cool. But that is becoming a larger and larger thing, is where you can find models. I did a project for Jim Guy a couple of years ago where we needed to find, it was this very specific period helmet that I was able to just find a model of and just print it. The Smithsonian has fantastic archive of stuff that you can download. You can download Abraham Lincoln's death mask and print it if you want to. It's crazy what's out there. I don't
And
know.
is your 3D printer, sorry.
What else?
Is your 3D printer wired into your computer like the way that you would have a regular computer or regular printer computer match?
Kind of.
Okay.
The new printers, the A1 Mini, the Bamboo Lab printers, they are usually, they're all set up so that you can just hook them up to Wi-Fi. So then when you download the slicer program for your computer, you can communicate as long as everything is on the same Wi-Fi network, they can communicate with each other. And that's pretty standard for the new printers. They usually have that capability built in. My older printers don't, but I have built using Raspberry Pis. That's what's in this little thing. Raspberry Pis are these little baby computers that you can do a lot of things with. You can make video game emulators. You can do security systems. You can do all kinds of stuff. It's just a little baby computer, less than $100. And these are even the cheaper ones. So these are only about 30, but each of these has an instance of a program called Octoprint. And I use that so I can control all of my prints from my computer. The traditional way, the simplest way, is to just use an SD card. And then you can just do it on the computer and then transfer the files that way. But yes, controlling from the computer is a much better way to do it because you have more stats. Also, it's one of the ways that I concede that AI is very useful because they have AI tools that'll watch the print and it can recognize whether the print, if it's doing like this, it'll be, oh yeah, that's really good. If your print looks like this, these are the same model. It can tell, well, it's supposed to be able to tell. It obviously didn't on this one, but it's supposed to be able to recognize if you're getting a spaghetti monster, if it comes unstuck from the bed. So yes, there are these fantastic tools now that let your computer communicate. So I can go home and actually log in from my iPad into an app that is downloaded onto these Octoprint boxes. It's called Octo Everywhere. And I also have just like a USB webcam hooked up to each one of them. So it's watching them so that I can watch them remotely. So I don't have to stay here all the time.
I think that answered, there was another question about, do you have to run your printers overnight when you have those 12 to 24-hour prints?
Yes, sometimes longer, depending on the size. The trick is a roll of filament is 1,000 grams. And so there's only so large of a piece that you can make. I do have one printer over there that has 2 nozzles on it, and it can do fun tricks. So it has 2 nozzles that'll work at the same time independently of each other. So you can have a hard material in one and a soft material in the other. You can print a chess set and have white in one and you get black in the other. You can have a delicate material that you want your piece to be made out of, and then you can use a water-soluble filament so that, and that's what people like, what they do a lot in like automotive, if they're making really high-end, really detailed models, you use the support material as water soluble, and then you just put it in water, and then after your print is done, the supports just dissolve and go away, and then you're left with the detailed print that needed all of the overhang support. Did that answer any questions?
Yeah. So the second part of that question was that actually came earlier was how does the printer know to print the boat? The Benji, does it just come with most printers?
Yeah, they come preloaded.
Test?
They came preloaded on this printer, but it's also a thing where they're ubiquitous online. Teaching Tech is the best Patreon/YouTube channel for 3D printing. It's this guy out of Australia, and he is very into 3D printing, racing cars, and goats. And those 3 things are actually pretty related in his world. But he has created a tool that's on GitHub where he can take you through the granular, nitty-gritty detail of figuring out how to calibrate an older printer so that you can get good quality prints out of it. Did that answer the question?
I think so. Folks can pipe up too. Patrick asks, what training should an artisan have as they enter the professional prop shop? I'm assuming, Patrick, this means as far as like 3D?
I can tell you that, well, one of the things I love about 3D printing is that like you learn everything. Like most of the stuff I learned was just going down the YouTube rabbit hole. And when you go there, you find people that come from all kinds of different spheres. A lot of people from like a cosplay world, of course, but gearheads, car makers. In fact, I've got some neighbors who restore old BMWs, and I've talked to them because they can't get parts. So we've discussed the idea of replacing like the plastic seatbelt holders. And now I can't remember what the question was again. What was the question again?
Oh, what training artisans should have?
So when one of the pieces of my training that I have actually found the most useful is my carpentry experience. So as a prop carpenter, that's kind of what my background always was coming up. I was a prop master, but when I was building, it was usually prop carpentry. And so I built a lot of furniture over the years. And I have found that things that I have learned and known from my skills at building furniture are directly transferable to 3D printing, to the point where there are things like when I was talking about being able to cut apart a model into smaller pieces, you can put dowels into it. And so it's so much like the same process of doweling pieces of wood, only you're doing it on the screen. You're cutting the parts off, and you can say, give me a dowel right there, and a dowel right there, and a dowel right there. And you can tell it what size you want it to be, and then it will generate the dowels, so then you just print the dowels. Another thing I actually like to do is I'll print something like this is a turkey. It's going to be a big, giant turkey in a bunch of pieces. I'll use PVC pipe for the dowels and just make the holes the same diameter as the PVC pipe. And then I don't have to worry about printing that either, because I usually have a bunch of scrap PVC around anyway. When you're cutting pieces together, and another thing is that they add new elements to the slicer programs all the time. You cut the parts like I did with that big giant dragon egg. You can cut the parts apart, but now you can do dovetails. In fact, hold on, I gotta go grab a thing. So another part of that project where I was doing the cats also had dogs. So this is a giant model version of it of the torso of a dog. And so you can see with the different colors of filament, the different pieces. And if you look right there, it's a dovetail, just like you do with woodworking. And so the pieces slide and lock together like a giant puzzle that I just made on my iPad and then made in 3 dimensions.
Rachel would like to know how environmentally friendly is the filament? Can it be recycled once it's printed? And does it off gas when it's printing?
Some of the higher temperature materials do off gas, and there are materials that you can get like ASA and ABS that you really want to make sure that you have ventilation. And I have this room is big enough, and I've got some limited ventilation, but I try to stay away from those filaments that require a whole lot of ventilation. But when you're getting like with the TPUs and the PETG, it's a good idea to have filter. Part of my goal is actually to enclose this whole rack at some point so that I have everything completely isolated and can vent the air completely out the side of the building. PLA though is it melts at a lower temperature and it doesn't off gas hardly at all. Nothing you would ever notice. Safe enough that I'm using it with the kids, and it's corn based. So that's not to say that it's like, super duper recyclable. It's still a biopolymer. It's still plastic, but it is sourced from corn. It's essentially cornstarch. So it is commercially compostable. We're getting to the point now where I have started to notice I'm seeing PLA in compostable silverware and drink lids. So yes, the answer is it's actually moving more in that direction, and it's becoming more sustainable. And I personally actually have, the more I think about it, this is called an additive technology. So you're building up layers, you're adding layers, as opposed to subtractive, which is what a CNC is, and foam carving. Like I could have carved this, going old school and carved this carrot out of foam, but it would have generated a lot of waste. So that's partly my goal here. Are the materials particularly environmentally friendly? No, because they're plastic, but I like it better than styrofoam. And it's reusable. And one of the things that a lot of people are working on is figuring out ways to recycle the plastic, grind it up, put it through a machine, melt it down, and re-extrude it. Varying levels of success, because the machining process has to be very exact, because if that filament isn't 1.75 millimeters all the way through, if you get any little bubbles or anything in it, it can clog up your nozzles. It'll clog up the gears, literally. So we're getting there. I have entirely too much plastic I've never thrown away, in the hopes that I get to a point where I will be able to reuse it. You can do things, you can also do things like grind it up and then melt it down, kind of like a friendly plastic, although it goes to a higher temp, but like you can put it into like an open silicone mold and put it in a toaster oven. It smells like crap. You got to off gas, because when you're trying to burn it like that, when you're heating it in that way, it will off gas. Because you've got to get it to a higher temperature in order for it to liquefy. But people do that. So there are definitely ways, and there are definitely a lot of people that want to do that, because, yeah. In fact, I saw somebody that was trying to do something similar by actually trying to turn a 3D printer into an injection molding machine using used filaments. So it's a goal, but nobody's really there yet with the technology.
Barkley asked about the clear PLA, about the ones that you used for the chimneys, for the chandelier. Is there anything you do finishing wise to make that look more like glass?
Brush it with clear ultraviolet resin, or a clear lacquer, or like a spray lacquer. There's a scientific effect for whatever it is about when you take something and it becomes translucent, because of, I don't remember what that word is, but it's that thing where like when you brush oil onto something and suddenly it looks really bright. It does the thing where it will fill the gaps in, and it takes some experimentation, but like a clear spray lacquer or a brush on clear ultraviolet resin can take something like this. And the trick is you got to get on the inside too. But you can take that. Oh, I got an example. This is a lampshade generated as a lithophane. So it was actually based on photographs. So it's actually relief photographs. But what I did is I printed this whole thing with clear PLA, or maybe clear PETG. I think it was PETG. And it was rough, and it looked like this. But when I brushed on the clear ultraviolet resin on the inside and the outside, you can see how clear it got. There's the answer to your question. That's how.
Patrick wants to know if the UV hardened resins glow on stage.
I don't know. I guess it would depend. It depends what kind of light you're fluorescing it at. You might be able to, like, if you actually threw some UV light at it on stage, you might get stuff to fluoresce on stage. I don't know. Maybe. That'd be fun to play with. Ooh, another thing that I didn't get to. The high end, so the Bamboo Lab printers, this is the $200 machine. The high end one, the highest end one that they have at the moment is the Bamboo X1 Carbon. It has a 256 millimeter build volume, 256 millimeters square. So most of the things in this table can fit on that plate. But what's really fun and really hot these days are multicolored prints. So that printer has a thing called an AMS, which stands for something material something. I don't remember what it stands for, but you can go back and forth between 4 different filaments and the base level, and it will automatically change those colors and purge and then go to the next one. Much like I did with the little one at the beginning where I was switching the filament, that thing will do it automatically. So this guy, he printed in 1, 2, 3, 4, 5 pieces, but each of those pieces came off the printer looking like that because it went back and forth between the gray and the blue and the white. And I think I actually used the luminous for some of these areas that can be backlit. And that's a crazy exciting development. The trade-off is you end up with poop. It poops material out the back of the machine when it's purging, when it's going to the new color. And there are newer and better ways that you can figure out how to avoid that waste in the slicer program. You can do things like, and that's actually one of the things I did when I printed that, you can set another object. So rather than it pooping out the back, it'll just poop into that other object and use that to purge the filament. And you will end up with something that doesn't have the right colors, but you can paint it. And that's another one of the things I love is that they will come along and be like, one day you download the new software, the new update for your slicer program, and you're like, wait, I can do that now? They came up with a new thing when, in order to mask seams, it's called a scarf joint. So normally it was just like a butt joint if you were doing something like this that had a seam going up and down it, but they created, somebody came up with with code so that it will actually make a little fillet for the seam and make it go away, make it disappear to improve the quality of the surface of your prints.
Isabel wants to know what you use in the brainstorming phase to show the concept to clients.
That's another good question. I oftentimes actually am able to use Shaper 3D. Like the perfect example would be the pontoon. I was able to do a variety of different things in order to visualize it for the client, because I was able to, once I had the thing drafted, I had a rough version of it, I could screenshot it. And then what I often do, if anybody has seen any of my stuff, I tend to do stuff with comic book format, and I'll create a proposal that uses comic book graphic novel style format using images that I have generated from the drafting program. And then on this one, this is a really rough version of it, but I was able to 3D print a model of that pontoon piece before getting too far along in that design process to make sure that it was right. And one of my favorite things that I was able to do is it's got an augmented reality function where you can load the model into the camera. So basically, you can look around the room in camera mode and load, and so it's doing the camera, and it will do a virtual reality where you can place the thing in the room. And I was able to do this. I went over to Can Wonderland. I knew I had the model at the right size. I knew where it wanted it to be. And I was able to use this, place the digital model in the room, and then walk around it like I was looking through a window into another reality where my piece existed. And they've taken it a step further now. This is the only drafting program I know of that you can actually use with Apple Vision Plus. And I tried it the other day. Crazy, because I went to a medical supply convention that had a keynote from the Mayo about how they're using 3D printing in heart surgery. So there were a lot of people there, but the company from Hungary who make this program were actually there demonstrating how you can use Shaper 3D on using the Vision Plus, and you can draft in it, but you can also use it as a way to demonstrate to a client what it looks like in real dimension, because when you had the thing on, you could just walk around the object and know that it was the right thing, or you could see different changes. So that's one of the fun things that I've been able to do, is be like, being able to get down to such a level of nitty-gritty detail with the digital model and then have creative ways to share it, that's what I've been doing a lot of lately. The iPad, I haven't had a laptop in years. I got rid of laptops. I have a desktop machine because I need it for the software for slicing because it needs that processing power. But all of my workflow is iPad and pencil based now, which makes it extra easy when you're communicating with a client. You can just be like, "Boop, here you go," or a director, same thing, or a set designer.
Sounds great. Well, that's all we have time for. There were a couple of questions around just the programs you were using. If you could provide links, can folks find that on your Instagram, or maybe we'll put it in the description to the YouTube video?
Yeah, we can do that. I think that might
Okay.
be the way to do it. This is it's a Google Doc, a living document. So I'm going to update it as I go too, as I find new stuff. In fact, I'll probably put the link to this video on that cheat sheet eventually.
Well, thank you, Sean. And thank you all for attending this evening. I hope it was a fun and informative evening. Next up in our Spaminar series on November 17th, Spam Secretary and Data Organizer Liz Bear will be talking with us about how to harness the power of Airtable at our props inventory systems. We'll be taking December off before we're back in January with a whole new slate of Spaminars. So please keep your suggestions coming. We want to know what you want to learn about. If you're interested in joining SPAM and are a working prop manager in a nonprofit theater, opera company, children's theater, or an educator who teaches prop classes, please visit our website or click the link in the chat to fill out our membership form. You can find us on Facebook, Instagram, and YouTube. Links are in the chat. Spaminar is produced by the Society of Props Managers with special thanks to SPAM members Patrick Drone, Freed, Ben Homan, Nikki Koulis, Jen McClure, Amy Peter, Sarah Pugh, Karen Robbie Vance, and Helen Strategas. Thanks again for attending. Prop on. We'll see you next time.